Good morning, everyone. My name is Mohammad Wasim Akram, working as an assistant professor in the Department of Civil Engineering of Alia University, Kolkata. Today, I am going to present my research paper on estimating groundwater contamination potential of a selected location of Nandigram, West Bengal, India, for sustainable area development. Groundwater contamination is a serious concern. Groundwater quality is increasingly affected by many human resources activities. Industrial activities that are shortly going to happen near to the Nandigram may increase the level of contaminants into the groundwater. The possibility of pollution in groundwater near Nandigram has been attempted by using a steady-state groundwater flow model. The findings of this study are of great importance in formulating protective measures to conserve groundwater resource in Nandigram. This figure shows the location map of the proposed research area. The study was conducted in Ahmedabad, Zone 2, Block Nandigram 2, Purba Midnipur district of West Bengal, India. The area falls in coastal alluvial plains that are mostly agriculture in nature, with intense agricultural practices and growing industrialization. This study aims at contributing to policy and practice in the area of groundwater protection by developing a framework for local authorities and other stakeholders. The objective of this research is to study the likely contaminant dispersion, particularly in Ahmedabad, Zone 2, Nandigram 2 block, West Bengal, and manage water resource to mitigate the risk of further deterioration of water quality through contamination. In this slide, I will discuss methodology and model used in the study. The steady state groundwater flow model for investigation into the dynamic of groundwater within the region selected in Nandigram area of West Bengal was used. Such models are really valuable for governing groundwater resources, assessing the impact of agricultural and industrial activities on the quality and quantity of water, and guiding the strategies for land use planning and environmental protection. The Mankandel test was applied to quantify trends in groundwater discharge at selected boundaries depth within the area of investigation. Values of discharge with lateral stretch calculated from the model. Actually, we have taken 4 depth, that is 1.5, 1.4 meter, 2.4 meter, 3.4 meter and 9.4 meter. Top depth is 0.6. It shows the ground level of groundwater table, and the bottom depth varies from 1.5, 2.5, 4 and 10 meter. The lateral stretch is taken as 2 by 2 meter, 4 by 4 meter, 6 by 6 meter, 8 by 8 meter and 10 by 10 meter for all the 4 depths, and for this input data the discharge is calculated from the model. In this slide, the whole statistics of Ahmedabad is summarized. As I have discussed, the 4 depth 1.4, 2.4 and 3.4 and 9.4 meters were taken, and for this 5 observations were taken for 2, 4, 6, 8 and 10 meter, and then for 200, 400, 600, 800 and 1000 meters, and the minimum and maximum discharge is calculated, then mean is calculated, and after that standard deviations are calculated from this. This figure shows the groundwater dispersion pattern for the all selected depth 1.4 meter, 2.4 meter, 3.4 meter and 9.4 meter for all the lateral stretches as selected. After that, Mankandel trend test graph were plotted. The graph is between drainage and horizontal width. Let me conclude now. Contaminant transport is an issue of great concern these days, especially because of the deleterious effect it has on the existing reserves of groundwater. The major percentage increase along the horizontal stretch of these depth indeed confirms the possibility of contaminant dispersion in case any industrial discharge takes place in the future. Currently, Ahmedabad remains in a very largely unexplored virgin condition with minimal to no industrialization. However, the finding of this study presents useful information that would be helpful in anticipating and preventing the risk of groundwater contamination when industrial development are set in place in the area. These are some references